Alright, next on my bench I have a Harman Kardon HK 550 VXI. It's a receiver. High voltage, high current stereo receiver. It has a special feature on the back with a switch. You can select between 4 ohm impedance or 8 ohm impedance. And I was just kind of looking over the circuitry, and it looks like it reconfigures the power transformer in the circuit to when you're on 8 ohm load, it boosts the rails on the power amplifiers, and I suspect when you turn it to the 4 ohm load, it cuts back on the voltage and boosts the current. So I guess that's what they're doing there. eBay junk, found it on eBay, good price, but unexpectedly this knob went missing from the time when I purchased it and from the time when the guys wanted to ship it. So he contacted me, he offered me a full refund, and he even offered to ship the unit out to me and give me a full refund, and I declined. I says, you know, it's not right that you take such a loss on the unit itself. And I asked him just give me a bit of a discount, so he knocked a few dollars off, and I'll look for another knob. Other thing is wrong with it, it's missing 1 foot, so I don't know what I'll do about that. Keep my eyes open for that too. But other than that, it's a nice clean unit. It's not damaged, it's not scratched, it's got like no nicks in the top. It's nice and clean. That way, it needs it's dirty, it needs a lot of cleaning up. But let's have a look at the inside. Even the lid, you can tell it's a low hours unit. It's nice and clean inside. So this does not have a removable bottom, so if I want to do any work I have to remove all of the printed circuit boards. But I just want to show you one thing. Okay, here's the one channel. I got it powered on right now, I'm going to shut it off. Here's the one channel. Looks nice and clean, and then I move over to the other channel and all hell breaks loose. These screws look like they're stripped, the Phillips, and there's blobs of solder on the bottom of the transistor legs, and somebody was monkeying around with the grease. So I don't know if somebody replaced these transistors. They're the original transistor part numbers, but they look like replacements, because this one looks original. It's green. What is that? That's a 2SA 1264, and this is a 2SA 1264 as well, but it's in black, so there's a bit of a difference there. So yeah, I want to go and check this channel out. I checked the idle balance, the bias idle adjustments. This is sitting at about 45 milliamps, or sorry, 45 millivolts, and this one's up around 56 millivolts, which is probably high, and this thing's in need of an adjustment. Other than that, it's a nice unit. I have one burned out light on the where is it? One burned out light on the LCD display, so I'll probably take those two out and put in some LEDs. It's got some TK caps, so I'm going to go through and make sure all these TK caps are working to spec, and it just needs a general cleaning. Like, it's all full of cat hair, so I'm gonna have to go take it out and blow the dust out of this thing. It's kind of nasty, but we'll get it going. As far as operation goes, it seems to be working fine. I was getting one low output on one channel. Getting low output in one channel, but this balance control is quite messed up. Left channel, you can see it's either cracked solder joint or it's going to need a good pot clean. Right channel seems fine. It's just that left channel. But I am able to get equal outputs on both channels. I got the scope hooked up in a tone. So yeah, so far it's working that way. Tuner works. So FM's coming in pretty weak. There's no signal strength indicator, so you can't really tell. But it doesn't seem to be picking them up as they should. It seems to be awfully... Oh, the seek is not working. It should be seeking on its own. It doesn't want to. AM. There's no antenna. Scan the band and it doesn't pick up anything at all. So it looks like a hell of a bit of work ahead of me here. And one more thing I forgot to mention is this power cord is pretty hacked up. So I'll be changing that as well. And you can see that. I don't know why it's chewed up so bad. I don't know if that was a pet chewing that or if that was somebody hacking at a knife with a knife. Looks like a knife. I don't see any copper. Well, there's a little bit of copper there. But it's going to get changed anyways. Oh, here's a big one. You can see copper there. There's another one. So, get a plug for this. Alright, so I got the receiver gutted pretty much. I wanted to take a look at the bottom of this board for two reasons. I wanted to see what that tech did with replacing those transistors, and I can see that he did absolutely nothing. These are factory solder joints, and he redid all the replacing of those transistors from above. So what he did is he snipped them off and mounted his transistors and then soldered the legs to whatever stumps that were left. And that's kind of a cheesy way of doing it. It's not the right way to do it. The other reason is I wanted to look for cracked solder joints, and lo and behold, I found some here on the drivers. So I'll show you what they look like. Alright, so you can see one here. Here, I'll point from this side. This transistor here. Look at that center connection, and I'll wiggle it from above. See, it's cracked. And then if I go over here, excuse the mess. Let me see if I can zoom in a little bit more. There's one right here. And if I wiggle it, you can probably see it moving a bit too. It's not as bad as the other one, but that's the reason why you want to get these boards out and have a look at them, because you kind of find all kinds of surprises under there. Yeah, you want to get that cleaned up. That's just going to cause you problems in the future. One thing you got to pay attention to when you're replacing a line cord is if you read it, it tells you a lot about its safety certifications. It's got 105 degree C rating. This one was made by Kawasaki. CSA type SPT2, 105C degrees. And then it tells you right here 2/18 AWG, which means 2 conductors of 18 gauge. So 18 gauge cord, you got to replace it with either an 18 gauge or something thicker. And here I got one here. Let's see here. If I can read this. It's got part numbers. Walson Liwa, I guess that's a manufacturer. SPT-2, 105 degrees C. AWG 16 times 2. So this is actually 16 gauge. It's thicker than the original, so we're good to go with this one. It's polarized. So we'll put this on. I don't have any new ones. I should get some new ones, but salvage them from old equipment. As long as they're not cut up and chewed up like the originals, they'll work. Hey, I just want to show you what Harman Kardon is doing with their VXI series amplifiers receivers. With regards to, on the back, they have the 4 to 8 ohm switch on the back of the unit so you can select 4 ohm loads or 8 ohm loads. I just want to show you what they're doing here. This schematic is taken from a PA 2100 power amplifier. Because I don't have the schematic for the 550 VXI, but this is just exactly the same thing. They do this in a lot of different models, and from what you can see here, we got just the power input from the line goes through a power switch and a fuse, and the primary of the transformer. Secondary of the transformer has extra windings. If you take, for example, let's see here. Well, the way it is set up now, the switch positions is to the outermost windings, and that gives you your most voltage on your AC secondary, and that is for your 8 ohm switch position. And when you flip the switch, these two switches switch to this position, and you are getting the current winding without the benefit of the extra voltage boost. You're getting a lower voltage here, but you're also going to get a somewhat higher current because the winding resistance will be lower. We're removing these two, so you're going to have a lower winding resistance. You're going to have a lower impedance for this transformer, and you're going to get a higher current. It's not much, but it's slightly higher. But then you also, in the trade-off, you're getting a lower voltage. So you're sending a lower voltage, higher current to the power amplifier, and that's what they're doing here. So basically, this switch is just to set the amplifier up for a 4 ohm load or an 8 ohm load. That's all it's doing. And you know how to benefit the take advantage of your 4 ohm speakers. You want to have it on a lower voltage and a higher current. Alright, we're all wired up to do a power test on the amplifier. Got both channels scoped, feeding it 1 kilohertz tone, and I'm going to keep going till it starts clipping, and then I'm going to measure the right here. We got 22.3 volts RMS and an 8 ohm load. Now that's in the 8 ohm mode switch that's set on the back, so that as far as I can tell, all it does is it provides the power amplifier with a higher voltage for driving a higher impedance load. Let's see, I got it at max right now, and the amplifier heatsink's getting quite a bit hotter than my load, my dummy load, so it's warming up pretty good. Okay, let's switch over to 4 ohm and do that. Okay, now we're going to do the 4 ohm load test. The amplifier is now configured for 4 ohm loads by the switch at the back panel. I have speaker system A at 8 ohm load and speaker system B at 8 ohm load. So first I'll run a test independently, then together. So if this first test is 8 ohms, and I'm going to jack it up until we get distortion, clipping right there, and I'm at 20.1 volts RMS. Okay, let's kick in the other load. So we got both loads. We got a 4 ohm load on now. Let's turn this up. And we're at 16.6 volts RMS on a 4 ohm load. I'm just going to let this cook for a while and see how it heats up. So with my blur, I can see it's getting kind of hot here. These driver transistors are at over 100 degrees Celsius right now. The heatsink itself is getting quite hot too. Let's see what we're at here. Oh. Yeah, we're over 100 degrees Celsius on these two. Yeah, it's been maybe 4 or 5 minutes, and I'm getting over 120 degrees Celsius on those 140 degrees Celsius on those transistors. So I'm shutting this down. I don't want to pop any transistors. Okay, well, I'm pretty much done with this. I did the alignment on the tuner. It really wasn't out very much, just a little bit of tweaking on the AM band, and that was all I had to do. The FM was bang on. So what I want to do is I want to fix this missing foot situation here. So I dig through my parts. I do have feet that are, well, this is actually, I think I measured 15 millimeters. And I do have feet that are 15 millimeters, just that they don't match. So I opted to find a pair of feet, and I'll just replace both rear feet, and it'll look symmetrical. Symmetrical, yes, that's a word. And then get this thing back on the countertop to listen to. But I have to remove this board to access the mount. So now I got the board out, I can get at the take the foot out, I can remove the other foot, and I can now bolt in my new one. So screw from above, so the and then a nut. It might not cooperate. I might have to lay this down. Actually, what I'd like to do, I'll put some Loctite on those so they don't come loose. And you want the screw short enough so it doesn't scratch the table top or countertop. So that's good. I'll put the other one on and we're done. So final thoughts on the receiver. It's been built down to a price. It still has those TK capacitors in there, and here I show you I replaced, how many did I replace here? 3, 5, 6, 7, 8, 9, 10, 11, 12, 13 caps. I pulled out of the tuner and the power amplifier. They were below spec. Replaced those. Put LEDs in the front for the LCD display. It's got a good build quality. Working on it's a pain in the ass because a lot of these wiring looms are soldered in and you can't disconnect them like this one. So you can't just take one board out without, being disconnected to 5 other circuit boards. So that way is kind of a pain. But yeah, I'll try this out and I'll see how it sounds. Still missing a knob, so I'll have to find that before I think about selling. So let's give it a try and see how it goes. Alright, thanks for watching.